Okay, so in this lecture, we will discuss about expressing analytical results. So in analytical chemistry, so it is called as a measurement science. So more often than not, you are measuring something uh, which is called your analyte, and your analyte is usually a portion of a larger sample size. So if this is your analyte, and then this is your sample. So you need to when expressing results. So it is commonly referred to as a part of a whole and is expressed as concentrations. So even on some types of analysis, so for example, detection of bacteria, so it's just a simple or a simple identification, there is a concentration involved. So for example, in the detection of bacteria in an example, so the U.S. Centers for Disease Control and Prevention, so they characterize a positive detection. So it's just a positive detection as one cell for every 25 grams of egg. So you see that there is still a concentration involved one cell per 25 grams, even though the result of this analysis is just positive for example, a salmonella. So this is the guideline for that specific bacterium in eggs. So in this regard, so we have some here. So 8 examples of the most common expression of analytical results used in analytical chemistry. Of course, there are also some other things in different fields. So, for example, you have in microbiology, which is the colony forming units per ml. So, this is the amount of bacterium that grows in a specific culture media per ml of your sample. So we will not go to those types of examples, and we will just focus into the more common ones used in chemistry. So the first three concerns the percent. So percent weight by weight, percent weight by volume, and percent volume by volume. So in this example, so this just differs on the phases that you are um, analyzing. So for example, so on the third one, volume by volume. So the easiest example in here is the alcohol. So 70% alcohol. So it's 70 ml of, for example, ethyl alcohol. Ethyl alcohol in 100 ml of solution. So that's 70% volume by volume. So, example naman ng weight by weight. So, for example, you have a mineral rock. So, and then you want to analyze what is the percent of dolomite in that specific mineral. So, you can express it as percent weight by weight. So, this usually percent expressions. So these are expressed as 100 in 100. So if weight by weight, so it's in 100 grams. If volume, it's 100 ml. So because if you remember the formula for percent usually, so it's like so grams, and then if you have volume times 100. So usually this the percent has that type of equation or formula. So now, after this percent weight by weight, and volume by volume, you have moles. So moles, so this does not clearly represent your sample, but this is usually used to determine the value of your analyte, especially if you have stoichiometric calculations beforehand. So for example, if you have the reaction of sodium hydroxide and hydrochloric acid to form sodium chloride and water, so if you know the concentrations of sodium hydroxide and then hydrochloric acid, you can solve stoichiometrically for the concentration of sodium chloride formed. So, so after you have evaluated this, so you can further calculate its percentage in the sample. And then, so more often than not, so when handling solutions, so you have these two concentration formulas, which the first one is molarity, and then the second one is molality. So molarity is mole solute over liter solution, while molality is mole solute over kilogram solvent. So it is important that you do not get confused with these two because the denominator is not the same. So not uh, they are not representing the solution. So so molarity represents liter solution while molality represents only kilogram solvent. So it's important to remember. So and then in large volumes or in situations where your analyte is very small amount compared to your system. So this is important in the analysis of, for example, heavy metals, which is dangerous to health, and aquatic wildlife, for example. So you have these two, which is parts per million and parts per billion. So ang pinagkaiba lang nila, so pwede mo siyang i-express pareho as mass over mass, or volume over volume, provided na parehas yung kanyang unit. So for example, if your mass nasa numerator mo ay grams, dapat grams din yung nasa denominator, and then i-multiply mo ng times -6. So which is worth a million. O 10 to the 6. So kahit na i-expand mo pa yan, so it is worth a million. And then parts per billion naman, so same lang din, pero times 10 raised to 9. So ngayon, yun namang ang ginagawa naman dito sa parts per million and parts per billion para hindi na sila mag-multiply ng times 10 raised to 6 and times 10 raised to 9. So ang ppm ay nagiging equal sa milligram per liter. And then the ppb becomes equal to nanogram, ppb ay nagiging equal sa microgram per liter. So kung ayaw mo naman ng milligram per liter, so pwede naman siyang microgram per ml. Yes, and then this is pwede rin nanogram per ml ang ppb. So makikita mo yung difference nila sa layo nila sa bawat isa. So these are the most common ways of expressing analytical results which you will encounter this semester. So to start off in your experiment 3 and 4, so in the experiment about percent moisture and percent ash. So you will be using the percent weight by weight expression. So that ends this lecture. Thank you for listening.